real quick, I want to go through the equation piece. So really all you need to know is you always need to get the radical by itself, and then you're going to undo it. So when I see a minus 9 out here that isn't with the radical, I need to add 9 to both sides to get the radical by itself. What do I get there? 3. Then I need to undo the cubed root. To undo the cubed root, we're going to cube both sides. So again, that's like having 5x raised to the 3 over 3 power. That's why when I simplify it, it's just 5x. On this side, 3 to the third is 27. And then I just have to solve that equation. Divide by 5. If you got a calculator, you can give me a decimal, or you can just leave it as 27/5. All right? Say with number 23, it's already by itself, so to undo a square root, I need to square both sides. And again, all of this is under the square root, so that's going to undo, that square is going to undo that square root. So I'm left with x plus 25 equals 2 squared is 4. Subtract 25 and I get negative 21. Now you should always take these and plug them back in and make sure they work. And this one would work. I'd get the square root of 4, which is 2. Okay. When I go over to the next page, again, even this, if there's a number out in front of there, you want to get the radical by itself. So before you do anything, divide by 2. A lot of you missed that on the quiz. Divide by 2, and you get the cubed root of x minus 3 equals 2. Then you cube. So I'll get x minus 3, 2 to the third is 8. Add 3 to both sides. I get x is 11. Plug it back in. Get the cubed root of 8, which is 2, times 2 does give me 4. If it's in exponential form, same thing. You either could write it as a cubed root if you would rather. Write it as a cubed root so that you know you want to cube both sides. But really all you need to think about is to get this to be 3x to the first power, I need to raise it to the third power. So that if I have this power raised to another power, I get 3x raised to the first. So you either can think of it as exponential, what do I need to do, multiply by, and raise to a power, so that when I multiply those I get a 1, or put it in radical form if you feel better with radical form, and then know that to undo that we have to multiply, or we have to raise both sides to the third power. So now I get 3x equals negative 3 times negative 3 times negative 3 is negative 27. So that is a negative number. When you cube it, divide by 3, I get negative 9. So again, if you put up here, you take 3 times negative 9 is negative 27. The cubed root of negative 27 is negative 3. So it does work when you plug it back in. All right, 26, we're going to subtract 20. So you have to get this base by itself first. So I subtract 20 on each side, divide by 5, and I get x to the 3/4 equals 8. And again, if you need to, think of this as the 4th root of x to the third equals 8, and now you see that you need to raise it to the 4th power. Okay, so you can do that, or you can look at this and say, what power do I need to raise this to get x to the to an integer power, or to the first power? I can multiply. I would need to multiply by the reciprocal 4/3. So if I take x to the 3/4 and raise it to the 4/3, I'm going to get x to the first when I multiply those two together because they're reciprocals. So whatever I do to one side, I have to do to the other. So now I get x here. Here I have to think of this as the cubed root of 8 to the 4th power. Again, we're just putting that into radical form. Cubed root of 8 to the 4th. Cubed root of 8 is 2. It's easier if you do that first. So 2 to the 4th power is, what, 16. Now, if you did it over here as a radical, so if you, instead of raising to the 4/3 power, if you thought of that as the 4th root of x to the third equals 8, you would have to undo the 4th root by raising to the 4th. You get x to the third equals, and you'd have to know what 8 to the 4th power is, or use your calculator to get that. So that's why that's a little bit tougher, because now you have a little bit bigger number to work with. Whatever that number is, I don't have a calculator with me, then to undo this, you'd have to take the cubed root of that. And so whatever 8 to the 4th is, if you took the cubed root of that, you should get the answer 16. So you could do it in radical form if you have your calculators, but again, it's a lot easier if you think of x to the 3/4. Just raise it to the 4/3 power, because that will give you x to the 1st. Same with 27. If you see x plus 2 to the 3/4, probably easier if you take and raise this to the 4/3 power. So here we're going to raise it to the 4/3 power. So again, we're raising it to a reciprocal power. So I'm going to be left with x plus 2. On the right side, I have 8 to the 4/3. I'll write that in radical form, cubed root of 8 to the 4th. So x plus 2 will equal the cubed root of 8, which is 2. 2 to the 4th power is 16. And then I'm going to subtract 2 on each side to get x is 14. All right, and then when we get to 28, we have x plus 6 to the 1/2. So again, you could think of that as the square root if you want to. The square root of x plus 6 equals x. And see that you have to square both sides. But again, if you have something raised to the 1/2 power, you can just say you want to raise it to the reciprocal power, so you want to square it. Because when I have a power to a power and I multiply those, I get x plus 6, my base, raised to the 1st power. But again, if it seems easier down here to see that if it's the square root of x plus 6 to undo it, I square it, you can think of it that way as well. So whatever way you look at it, you have to square both sides. So you're going to be left with x plus 6 equals x squared. So now I need to set everything equal to 0. And this is factoring, so you have to make sure that you're okay with factoring. Pair of factors of -6 that add up to -1. Are those two factors? And so when I set each of those equal to 0, I get 2 answers. I have to check both answers, so if I put in a 3, square root of 9 is what I get up here, or 9 to the 1/2, square root of 9, it does equal 3. When I put in -2, I get the square root of 4, because 6 plus -2 is 4. Square root of 4 does not equal -2, so I cancel that one out. 29, same thing. I'm going to square both sides, but remember, over here, I have to square that entire side. So I'll get 10x plus 9 on the left side, but on the right side, I have to multiply x plus 3 times x plus 3. And so I'm going to get 10x plus 9 equals, when I distribute these out, I'm going to get x squared. I'm going to get 3x plus 3x, so I'm going to get 6x, and then 3 times 3 is 9. So now I have to set everything equal to 0, subtract 10x, subtract the 9. So I'm left with just x squared minus 4x. Sometimes this is the hardest one to factor. You need to recognize that you have to factor it because it's a quadratic, but you have 2 terms, they have an x in common. So factor the x out. You don't really have to think of a pair of factors like you did when we had a trinomial in number 28. So now I just set this factor equal to 0, I get 0. Set x minus 4 equal to 0 and solve it, I get x is 4. Plug it back in up here to the original problem. So when I put in a 0, I get the square root of 9, which is 3, equals 0 plus 3. That's true. With the 4, I get the square root of 49, which is 7. That equals 4 plus 3. So in this case, both of those work when I plug them back into the original problem. All right, in numbers 30 and 31, same kind of problems, but now you'll see you have square roots on both sides. So you've already got our square root by itself. So all I need to do is square both sides. So when I do that on both sides, because they're both all under the square root sign, I'm just going to get 2x plus 5 on the left. But on the right, because this is the square root and I've squared it, I'm just going to be left with x plus 7. So now just solve that equation. Subtract x, subtract 5. I get x is 2. We need to check it. So up here, the square root of 2 times 2 is 4, plus 5, square root of 9 is 3, equals, when I put a 2 up there, square root of 9 is 3. It works. Same with this one, except for now I'm going to cube it. So when I cube it, I get x minus 9 equals 2x plus 1. When I solve it, I get x equals negative 10. So if I plug it back in, I'll get the cubed root of negative 19 equals the cubed root of negative 19, and it works.